Welcome back to the channel. If you haven't seen part 1, be sure to check that out. We covered real-world wins and costly failures that exemplify the first 5 of the 10 principles of engineering economic analysis. These principles are drawn from the classic textbook Fundamentals of Engineering Economic Analysis, First Ed, Wiley Inc., and are used to make smart engineering and investment decisions. In this video, we'll finish the set by exploring real-world successes and missteps that showcase principles 6 through 10. Again, this is just a brief overview for each example and concept. In future videos, we'll go deeper into concepts that support these principles, using specific tools, calculations, and case studies. Additionally, while other factors may have come into play in these scenarios, we will focus just on the part that the applicable principle played in each example. Let's dive in. Principle 6. Keep investing while return is greater than cost of capital. If your project's return is higher than the cost of funding it, keep investing. That gap between return and capital cost is where real value is created. Real-world win. Amazon's Relentless Reinvestment, 1997 to 2018. Amazon is one of the clearest examples of this principle in action. From its IPO in 1997 through the late 2010s, Amazon reinvested nearly all of its earnings, even when profits were slim or non-existent. Their strategy? Go all in on infrastructure, logistics, and especially cloud computing through Amazon Web Services, AWS. In 2001, Amazon's revenue was $3.1 billion. By 2018, that number skyrocketed to over $232.9 billion, according to SEC filings, and AWS became the crown jewel. In 2018 alone, AWS brought in $25.65 billion in revenue, making it a major driver of Amazon's overall profit. Even in years with overall net losses, Amazon's strategic reinvestments consistently outperformed their cost of capital. They weren't gambling, they were compounding. Real-world misstep. WeWork's Overexpansion, 2016 to 2019. Now let's look at what happens when that principle gets ignored. Between 2016 and 2019, WeWork spent aggressively, leasing premium office space, acquiring startups, and launching ventures like WeGrow and wellness resorts. But the problem? Their investments didn't generate returns above their capital costs. According to their 2019 IPO filing in 2018, WeWork earned $1.8 billion in revenue, but lost $1.9 billion. Their valuation crashed from an estimated $47 billion to under $8 billion after their failed IPO. CEO Adam Neumann resigned. Over 2,400 employees were laid off. SoftBank, one of WeWork's investors, was forced into a $9.5 billion bailout. Unfortunately, WeWork failed to live up to its name and did not use its funding wisely. The result? A collapsed IPO, mass layoffs, and a massive erosion of shareholder value. Unchecked growth without returns above the cost of capital is a recipe for collapse. The lesson? Chase value, not just growth. If your returns are higher than your cost of capital, keep investing. But the moment they fall below, stop, reassess, and redirect. That's not just smart finance, it's disciplined economic thinking. Principle 7. Focus on differences in cash flows. When comparing engineering or investment options, don't get distracted by costs that stay the same across alternatives. Instead, focus on the differences in future cash flows. That's where the decision lies. What varies between your choices, costs, revenues, savings, drives smart economic decisions. We will go over many of the economic terms used in this section in later videos. World example: FedEx's aircraft modernization, 2011 to 2014. In the early 2010s, FedEx confronted a key operational choice: continue flying older, less fuel-efficient aircraft like the Boeing 727s and MD-10s, or invest in a modern fleet of Boeing 757s and 767s that could significantly cut running costs. Shared overhead, like pilot salaries, hangar expenses, and air traffic control, remained constant. The real economic benefit lay in the differential cash flows. Newer aircraft offered up to 36% greater fuel efficiency compared to the older jets. In 2013, FedEx reported a cumulative fuel and emissions saving of over 83.9 million gallons of jet fuel, with modernization being a major factor. This is textbook engineering economics. When fixed or shared costs, like hangar space or pilot salaries, remain constant across alternatives, they don't influence the decision. What truly matters are the differential cash flows, like lower fuel consumption, reduced maintenance costs, and improved aircraft reliability. Real-world misstep. Kodak's digital delay, 1990s to 2000s. Kodak was once a global giant in photography. So dominant, in fact, that it invented the digital camera in 1975. But instead of leading the digital revolution, Kodak hesitated. Why? Much of Kodak's revenue relied on its highly profitable film, paper, and chemical processing business, products deeply tied to its analog infrastructure. The company seemed to fear that fully embracing digital would cannibalize its core revenue streams. Rather than focusing on the differential cash flows like lower production costs, rising consumer demand for digital, and faster distribution, Kodak prioritized protecting its legacy assets. It underestimated just how quickly consumer preferences and technologies were shifting. By the early 2000s, competitors like Canon, Sony, and Nikon had captured major digital market share. While Kodak eventually tried to catch up, launching digital cameras and online photo services, the shift came too late. Its revenues collapsed from $16 billion in 1996 to $4.11 billion by 2012. That same year, Kodak filed for Chapter 11 bankruptcy protection. Kodak focused too much on sunk costs and not enough on the changing cash flow landscape. In economic terms, they failed to act on the value of incremental benefits, the cost savings and revenue potential of digital technology, until it was too late. Here's the bottom line. When comparing options, don't waste time on costs that stay the same across alternatives. Instead, look at the differential cash flows, the specific costs or savings that change depending on which path you take. FedEx made strategic fleet decisions based on real differences: lower fuel costs, reduced maintenance, and improved reliability with newer aircraft. Kodak, on the other hand, got stuck defending legacy revenue and infrastructure. Whether you're an engineer, investor, or project manager, the principle is clear. Focus on the cash flow differences. That's where better decisions begin. Principle 8. Use a common time frame. When projects span different lengths of time, you should not compare them just by looking at total or upfront costs. To evaluate your options accurately, normalize all costs and benefits to a common time frame. We explore this concept more in later videos. Positive example: Texas Department of Transportation, concrete versus asphalt design, 2015. Let's say you're building a new road in Texas. You have two options. 1. Rigid concrete, which normally costs more to build, or 2. Flexible asphalt, which is cheaper upfront but wears out faster. At first glance, asphalt may seem like the better deal since it is less expensive to lay down. However, over time, asphalt needs more frequent repairs, resurfacing, and sometimes even full replacement. Concrete, on the other hand, lasts longer and needs less maintenance. So how do you decide which is actually cheaper? If you are the Texas Department of Transportation, you evaluate both options over a standard 40-year period, which covers the expected lifespan of both well-built flexible and rigid roads. By calculating the total cost of owning, maintaining, and operating each type of road over 40 years, they get a much clearer picture of long-term value. In high-traffic areas, where roads experience heavier wear and tear, concrete often wins. Even though it's more expensive to install, it pays off over time with fewer repairs, lower long-term costs, and less disruption to traffic. This is a perfect example of why we use a common time frame. Comparing just the upfront costs would have misled decision-makers. But by looking at the full life cycle, Texas saves millions and keeps traffic moving more smoothly. Cautionary tale: Pacific Gas and Electric Substation and Equipment Strategy, 2010s. In the 2010s, PG&E faced a mounting challenge: aging electrical infrastructure across its network, including substations and high-voltage transmission equipment. Rather than investing in widespread long-term replacements, PG&E appeared to have opted for short-term fixes and deferred maintenance strategies. From an economic decision-making perspective, these choices were not consistently evaluated over a shared lifecycle timeframe. Over time, PG&E spent billions on repeat maintenance and repairs that may have seemed cost-effective annually, but were more expensive over the long run. One high-profile equipment failure involved a worn suspension hook on a 97-year-old transmission tower. That failure contributed to the ignition of the 2018 Camp Fire, which became California's deadliest wildfire. While multiple factors were involved, including weather, vegetation, and regulatory oversight, the decision not to modernize aging equipment played a role. PG&E ultimately faced over $24.5 billion in civil liabilities, filed for bankruptcy in 2019, and pleaded guilty to 84 counts of involuntary manslaughter in connection with the fire. This case highlights the risks of focusing only on short-term repairs without evaluating the full economic impact over the system's lifecycle. While not the only cause, this failure to compare options on a common timeframe likely contributed to costly and catastrophic outcomes. When comparing projects or investments with different durations, always normalize costs and benefits to a common timeframe. This ensures you're comparing options fairly, whether it's evaluating road materials over 40 years or power infrastructure over decades. The Texas Department of Transportation example shows how long-term analysis can uncover better value, even when initial costs are higher. Meanwhile, PG&E's costly short-term repair strategy highlights the danger of ignoring full life cycle comparisons. The lesson: short-term savings can be deceptive. Smart economic decisions require a clear view of long-term value, measured on equal footing across time. Principle 9. Risk must justify return. Taking big risks can unlock big rewards, but only if the potential return justifies the uncertainty. High-risk engineering or business decisions need correspondingly high expected payoffs. Smart risk. Netflix's pivot to streaming, 2007 to 2010. In 2007, Netflix took a bold risk, investing in streaming video while DVD rentals were still profitable. They bet on future broadband internet growth and changed how people consumed media. By 2010, streaming overtook DVDs, and today Netflix leads a multi-hundred-billion-dollar company in a streaming market projected to exceed $1 trillion by 2030. Real-world misstep: Quibi's $1.75 billion gamble, 2020. Quibi launched in April 2020 with $1.75 billion in funding, aiming to deliver short, high-quality videos on mobile devices. But people were already watching free short videos on YouTube and TikTok, and weren't interested in paying for similar content. Within 6 months, Quibi shut down with fewer than 500,000 users, and its assets were sold off. This shows big risk without solid demand or return potential leads to fast failure, no matter how much money you start with. In summary, risk itself isn't the problem, unjustified risk is. Ask: does the return potential truly outweigh the risk? Only then is risk worth taking. Principle 10. Ignore sunk costs. Money or effort already spent is a sunk cost. Don't let past investments control your future decisions. Focus on what lies ahead, not what's behind. Smart exit: Google's shutdown of Google Glass consumer launch, 2015. Google spent millions developing Google Glass, an early augmented reality headset, but public skepticism, privacy concerns, and technical limitations showed it wasn't ready for consumers. Rather than pouring in more money, Google ended the public-facing project in 2015 and shifted focus. That allowed them to reallocate resources to other successful efforts like Google's Pixel phones. Letting go of sunk costs gave Google the agility to pivot and succeed elsewhere. Real-world misstep: Ford's investment in Argo AI, 2017-2022. In 2017, Ford invested about $1 billion into Argo AI, an autonomous vehicle startup aiming to lead in self-driving car development. But as the reality of fully autonomous technology proved more distant, the challenges mounted. Still, Ford continued investing, delaying a more flexible strategic pivot. In late 2022, Ford shut down Argo AI and wrote off its entire investment, resulting in an approximate $2.7 billion loss. This shows the danger of letting sunk costs drive decisions, draining resources and missing better opportunities. Sunk costs are in the past, whether time, money, or effort. If it's spent, it's gone. Make decisions based on future value, not past losses. And there you have it, the final 5 principles of engineering economic analysis. Together with the first 5 principles we covered in Part 1, these ideas form the backbone of smart, data-driven engineering judgment. In our future videos, we'll break these principles down even further, showing you how to apply financial modeling techniques, risk assessments, and cost optimization strategies to real projects. If you found this helpful, hit like, subscribe, and turn on notifications so you don't miss the deeper dives. Until next time, design smart, think economically.